Welcome to the class on vectors. Let's study vectors. Now the question says, in the triangle ACD, A, C, and D, B is the midpoint of AC. B is the midpoint of AC. E is the midpoint of AD. AB is given as 6A plus 3B. DC is given as 5A plus 2B. Express as simply as possible in terms of A and B. We have to express AC, AD, and then we have to prove something. Now, first of all, let me draw some colored arrows over here, colored line segments, colored vectors. Now, this is AB and this is BC. Since B is the midpoint, therefore, the purple vector and the green vector is exactly the same. So this is also 6A plus 3B in this direction. So AB is given as 6A plus 3B. And BC becomes 6A plus 3B because B is the midpoint. In other words, AC is 2 times 6A, or we can add it up. That is 12A plus 6B. That's one thing. And that is the first thing that they have asked, which is 12A plus 6B. Now, the second thing is about AD. Now, we have to create a path. A till D, D till C, that is the same thing as A till C. That's one approach. Other approach is AC plus CD. So CD will be the opposite, the negative of this one. AC plus CD is equals to AD. Any which way, you can work it out. So let me get started with this idea. AD plus DC is AC. AD plus DC is equals to AC. Therefore, if I make AD the subject, that is AC minus DC. What is AC? That's 12A plus 6B. And what is DC? That is 5A plus 2B. So 12 minus 5, that is 7A, and 6 minus 2, that is 4B, that is AD. Now this thing is completed. Now, what do? We also now have, let me draw this whole thing in one line with a green marker like this. So now this is known. Let me mark it in 2 steps. This is one thing, and this orange one is the other thing. Now the question says, show that EB is parallel to DC. Now this is DC over here, and I need to find what is EB. Now, first of all, what I can do is that, let me draw one more arrow this way. And I have just found AD. Now let me write it. I have just found AD, which is how much? 7A plus 4B. And since E is the midpoint of A and D, therefore AE is half of 7A plus 4B, which is 7 over 2A plus 2B. That is AE. Is everyone clear on this? Let me go through it. First of all, this was given. Since B is the midpoint, this is also the same. If I add these two, that is 12A plus 6B. The second point was asking for this whole thing. So from A till D, that's the root that we are taking. And then from D till C, that is the same thing as AC. So that is what I have done over here. AD plus DC is AC. Make AD the subject. That's AC minus DC. That's AC minus DC. It simplifies to this. Now I'm working on this part. Prove that, show that EB is parallel to DC. Now, what do we mean by that? I'll just come to that in a short while. Let me first find the vector. E is the midpoint. Therefore, if I have AD, half of that will be AE, or half of that will be ED, just like this. So AE is this much. But I'm interested in AB. So A till E, E till B, that's AB. So A till E plus E till B, that is AB. So therefore, EB is AB minus AE. What is AB? Do we have AB? Definitely, that's 6A plus 3B. And what is AE? We just found it over here. That is 7 over 2A plus 2B. That is 7 over 2A plus 2B. Let's do the subtraction. This 6. This is 7 over 2 is 3.5. So that's 5 over 2A. And 3 minus 2, that is B. This is EB, that what I have obtained. So far, so good. Do we have DC? There it is. This is DC, 5A plus 2B. DC is 5A plus 2B. Now let's compare the two. But before that, let's take LCM. Can I write this thing as 5A plus 2B divided by 2? Can I write this thing as half of 5A plus 2B? Yes. Now I can make the comparison. Focus on this, focus on this. Isn't it exactly the same? Isn't EB half of DC? Yes. So I have proven that EB is half of DC. This number over here, this is known as a scalar multiple, a constant. In simple words, it's just a constant. So if I take EB and if I divide it with DC, I am getting half. What does it mean? It means that these two vectors are parallel. So now the rule is, if vectors are parallel, one vector is a constant times the other, or one vector divided by the other vector is a constant. Hence, I have proven that these two vectors are parallel. Now, let me add something more to it. Something which the examiner has not asked, but maybe it will ask in the future. So let me draw a box over here and let me ask that question. That question is that since I have just proven that EB is half of DC, the first thing is, what is the ratio of area of triangle, the small one, which is AEB to area of triangle ADC? That is the ratio of the length squared, which is 1:4. So now this is just the similar triangle that we just reviewed. This is 1. This whole thing is 4. This whole thing is 4. Therefore, just this much is 3. So therefore, the examiner can also ask area of triangle AEB to area of trapezium. What's the name of the trapezium? EBCD. EBCD, that is 1:3. Because basically this 3 is this 4 minus 1. So that is the kind of ratio question that the examiner can ask. Let me move to this question. Now it's again about vectors. And now the question says, OABC and OPQR are parallelograms. So this is OABC, OPQR. These are parallelograms. A is a point on OP. A is a point on OP. And C is a point on OR. C is a point on OR. OA is A, that I can see. OC is C, that you can see. OA is to OP is 1:4. So OA is to OP is 1:4. Let me label it. Therefore, AP is 3A. Therefore, OP is how much? 4A. And OC is to CR is 2:3. So OC is to CR is 2:3. So let me write it. OC, CR, that is 2:3. Therefore, OC is 2/3 of CR, or I can say CR is 3/2 OC. That looks better because the C is already given. So this is 3/2 C from here till here. Therefore, if I need OC, which I might, OC is given actually. If I need OR, that is C plus 3/2 C, which is 5/2 C. I've also written it down. Now, first, it's asking for find OR in terms of C. Find OR in terms of C. Coincidentally, I have just found it. So this is the working which I have done for myself without the examiner asking. So this is 5/2 C. So that is the first thing that I have done. Now express CQ as simply as possible. What is CQ? So I have to go from C all the way till Q. So let me go from C till R and then R till Q. Now, since it's a parallelogram, opposite sides are parallel as well as equal in length. In other words, PQ is the same thing as 5 over 2R. In other words, this is A and this is 3A. So this is 4A. So therefore, going from C till Q is C till R and R till Q. So let me write this thing as CQ is C till R plus R till Q. What is CR? So first of all, CR is 3 over 2C. 3 over 2C. And what is RQ? That is 4A. So this is as simply as possible. You can switch around the places. This is 4A plus 3 over 2C. Now it's asking for ratios. Find the ratio of area OABC and area OPQR. Now OABC, that is OABC and OPQR. Are these two similar triangles? Yes, they are. The ratio of this to the whole thing is 1:4. So therefore, the ratio of the areas is 1:4 square. That's as simple as this. So this is to 1:16 because this is 1:4, the whole thing square. Let's move on. Let's try out some other question of vectors from the previous years, some good questions. Now, these are based on column vectors. We have PQ, 3 and -9. And what else is there? There is this thing, that is PR, which is H and -6, QU is 7 and 2, P is 17 and K. Now, there are 3 parts that we need to focus on. Now, what are those 3 parts? Let's think about it. The first one is, that is the first one. Let me work in red. Given that R lies on PQ, find the value of H. Now, this is something that people asked yesterday after the class. That is, this is about collinear points. So this is P, this is Q. Somewhere here might be R, it could be outside also. We don't know for sure, but definitely they are collinear points. So when we talk about collinear points lying on the same straight line, if we study coordinate geometry, it means the gradient of PQ and the gradient of, I think this one is R. Let me label it. So this one is R. Gradient of PR is the same thing as gradient of RQ. That is if we study coordinate geometry. But if we study vectors, so I'll say vector PR is parallel to vector RQ. It's parallel to vector PQ. So all these vectors are parallel. This one, the whole thing. Now, do we have PQ? Yes, we have PQ. So PQ is already given over here. So I'll use this one for sure. So PQ is given as 3 and -9. Now, I don't know, do I have PR? Yes, I have PR also. And PR is H and -6. So basically, I'm using these two. If 2 vectors are parallel, they are scalar multiples of one another. So either I can say, I have 2 options to write. So I can say PQ is a constant times PR, or I can write the other way around. PR is another constant time PQ. It doesn't make a difference. It's just simple 2 equations. PQ is 3 and -9. K is K. PR is H and -6. The first equation is for the x coordinate. T3 is equals to K times H. And the other equation is for the y coordinate. -9 is K times -6. Make K the subject, that is 3 over H. Make K the subject, that is -9 over -6. So therefore, 3 over H is 9 over 6. The negatives cancel out. So H is 3 into 6, 18 divided by 9. It comes out to be 2. That is one way of working it out. Now, if I look closely, basically it's the ratio of the x coordinates. This is the ratio of the y coordinates. So the shortcut, let me apply it. That is the ratio of x is to x. That is H is to 3. That's the same thing as -6 into -9. Naturally, H comes out to be 2. So this is a shortcut. This is just like similarity. Ratio of height is to height, base is to base. That will give us the answer. So that is the first part. The second part, it says express PU as a column vector. So now you have to develop a link. PU, we have PQ and we have QU, and PQ plus QU is PU, as simple as this. So PQ, let me write it down. Second part, PQ plus QU is PU. So therefore, what is PQ? That is 3 and minus 9. And what is QU? QU is 7 and 2. And that is PU. So 3 plus 7 is 10. And minus 9 plus 2 is negative 7. That is the answer that we get for PU. So the second part is done. What else is there? Given that U is the midpoint of QS, so we don't have QS, we have PQ, we have PR, we have QU, we have PS. We can find QS. Yes, we can find the value of Q. Now, first of all, let us find a QS. Do we have a QU? Yes. And do we have PS? So let's connect the two. So let me just copy this thing and let me take it on the next page, because I'll be using this particular diagram. So let me just copy it and let me add a page to it. That's right over here. That's good. And let us develop a link. Now, first of all, we have QU, which is over here. And then we have US. Do we have US? No, but it's common sense. This is P, this is Q, and this is S, and somewhere here is U. So we have QU. This is 7 and 2. Therefore, since U is the midpoint, US is also 7 and 2. So QU is 7, 2. That's the same thing as US. So in other words, find the value of Q. Now, what we can do is that let me add PQ and QS, and that will be PS. So basically, I found QS. PQ was already given. PS is already given, which has this K in it. So what is PQ? That is 3 and minus 9. What is QS? That is 14 and 4. Basically, it's 7, 2 plus 7, 2. That's 14, 4. That is PS. And what is PS? That is 17 and K. The first line is for double checking. 3 plus 14 is 17. That's perfect. That means minus 9 plus 4 equals to K. So K is minus 9 plus 4. Therefore, the value of K comes out to be negative 5. So that's how we did some questions on vectors. That completes the review of vectors.